menstrual cycle refers to the regular changes in the activity of the ovaries and the endometrium that make reproduction possible. The endometrium is a superficial layer of the uterus, and it consists of a thin base layer and a functional layer, which is subject to these changes. So, the menstrual cycle actually refers to two interconnected and synchronized entities: the ovarian cycle, centered around the development of the ovarian follicles and ovulation, and the uterine cycle, centered around the way in which the functional endometrium thickens and sheds in response to ovarian activity. At a certain point during puberty, menarche will occur, which is when a girl has her first menstrual period. From this day, the menstrual cycle starts and will continue to cycle until menopause, which is when the menstrual cycle stops. The menstrual cycle can vary from 20 to 35 days, but will refer to an average 28-day menstrual cycle. A new menstrual cycle begins on the first day of menstruation, and ovulation occurs 14 days before the beginning of a new cycle. So for an average 28-day menstrual cycle, this means that the pre-ovulatory and post-ovulatory phase both last 14 days. The 2 weeks before ovulation is the ovarian follicular phase, which corresponds to the uterine menstrual and proliferative phase. The 2 weeks following ovulation is the ovarian luteal phase, which corresponds with the uterine secretory phase. So, let's start with the ovarian follicular phase, which starts on the first day of menstruation and represents weeks 1 and 2 of a 4-week cycle. The whole menstrual cycle is controlled by the hypothalamus and the pituitary gland, which are kind of like the masterminds of reproduction. The hypothalamus is a part of the brain that secretes gonadotropin-releasing hormone, or GnRH, which causes the nearby anterior pituitary gland to release follicle-stimulating hormone, or FSH, and luteinizing hormone, or LH. Before puberty, GnRH is released in a steady amount, but once puberty hits, GnRH is released in pulses, sometimes more and sometimes less. The frequency and size of GnRH pulses determines how much FSH and LH will be produced by the pituitary. Pituitary hormones control the maturation of the ovarian follicles, each of which is initially made up of an immature sex cell, or primary oocyte, surrounded by layers of theca and granulosa cells. On the surface of the ovaries, a couple of ovarian follicles compete with one another to grow the fastest during each menstrual cycle. During the first 10 days, theca cells develop LH receptors, which allows them to bind LH, and in response they secrete a large amount of androstenedione. Granulosa cells develop FSH receptors, which allow them to bind FSH and produce an enzyme called aromatase. Aromatase converts androstenedione from the theca cells into 17-beta-estradiol, which is a member of the estrogen family. As follicles grow, the level of estrogen in the blood increases, and it acts as a negative feedback signal. That is, it tells the pituitary to secrete less FSH. Less FSH in the blood means there's only enough to stimulate one follicle. The follicle that has the most FSH receptors grows the quickest and becomes the dominant follicle, while the rest of the follicles regress and die off. Meanwhile, during the first few days of the cycle, the uterus goes through the menstrual phase, which is when the endometrial lining, also called the functional layer from a previous cycle, along with some blood, is shed and eliminated through the vagina. During days 10 to 14, in addition to the FSH receptors, the granulosa cells also begin to develop LH receptors. Meanwhile, the dominant follicle keeps secreting estrogen, and the rising estrogen levels make the pituitary more responsive to the pulsatile action of GnRH from the hypothalamus. As blood estrogen levels start to steadily climb higher and higher, the estrogen from the dominant follicle becomes a positive feedback signal. That is, it makes the pituitary secrete a whole lot of FSH and LH in response to GnRH. This happens a day or two before ovulation, and the massive surge of FSH and LH binds to the granulosa and theca cells, which help facilitate rupture of the ovarian follicle and release of the oocyte. You can think of it this way: for the most of the follicular phase, the pituitary saves its energy, and when it senses that a dominant follicle has really proven itself, the pituitary uses all of its energy to secrete enough FSH and LH for ovulation. The spike in estrogen is aimed at optimising the chance of fertilisation, which is highest between day 11 and day 15 of an average 28-day cycle. During that time, the high estrogen levels change the consistency of the vaginal mucus, making it more hospitable to incoming sperm. Additionally, the uterus goes through the proliferative phase, which is when the functional layer of the uterus thickens and the uterine glands grow. During this phase, spiral arteries emerge from the basal layer to serve the growing endometrial layer. Right after ovulation, while the LH levels are still high, the remains of the follicle turn into the corpus luteum, which is made up of luteinized theca and granulosa cells. Luteinized theca cells respond to the low concentrations of LH after ovulation by producing progesterone, but luteinized granulosa cells also secrete inhibin, which inhibits the pituitary gland from making FSH, so estrogen levels then fall. Overall, this means that progesterone surpasses estrogen as the dominant hormone, and it makes the endometrium receptive to the implantation of a fertilized gamete. Progesterone acts as a negative feedback signal on the pituitary, so FSH and LH levels fall. Progesterone is like an alarm, letting the body know that ovulation has occurred and that it's time to halt LH and FSH production until the next menstrual cycle. Under the influence of progesterone, the uterus starts to go through the secretory phase. That's when the spiral arteries grow even longer and the uterine glands secrete more mucus. After day 15 though, the window for fertilization starts to close. The cervical mucus starts to thicken and becomes less hospitable for the sperm. Over time, the corpus luteum is gradually replaced by a white scar called the corpus albicans. The corpus albicans doesn't make hormones, so estrogen and progesterone levels slowly decrease. When progesterone reaches its lowest level, the spiral arteries collapse and the functional endometrial layer gets ready to slough off. This leads to menstruation and the beginning of a new menstrual cycle and another attempt at fertilization. Alright, so as a quick recap, the menstrual cycle begins on the first day of menstruation. For an average 28-day menstrual cycle, the changes which occur in the ovary during the first 14 days are called the follicular phase. Ovulation occurs at day 14 as a result of the estrogen-induced LH surge. The last 14 days are the luteal phase. The follicular phase begins with menstruation, and while the length of the follicular phase can vary, the luteal phase always precedes the onset of menses by 14 days. For the uterus, during the first 14 days, it goes through the menstrual phase and the proliferative phase, and during the last 14 days, it goes through the secretory phase. Hi everyone, Sarah here. Thank you for watching that video on the menstrual cycle. I hope you enjoyed it. The script was written by Viviana. It was edited by Rishi, Tajal and Randy. I did the illustration and the voiceover, and the whole thing was edited by Sam. So thanks to everyone who helped out with the video. And if you liked it and you like the other videos on the Osmosis channel, then make sure you head over to osmosis.org, where there are tons more videos as well as another load of resources which is super useful. There are flashcards, question banks and the works for medical school, so that's a great thing to sign up for. And also make sure you head over to our Facebook page, Twitter and Instagram and leave us some feedback. We love to hear what you've got to say. Thanks, bye!